New question, question 58. We're very close to finish answering this exam. Um, I'll read for you and then we'll start. An electron in motion with a constant velocity v enters a uniform magnetic field B perpendicularly, which is important. Given that MEEV represent the mass, charge, magnitude of the electron's velocity respectively, which of the following statements is false? So, um, just to emphasize something, this question is hard because you just need to tell them what is false, and it's hard because unless you're very familiar with the subject, you need to do some work in order to make sure. But regardless of the correct answer being in our variation of the test being A, you have to sentences, regular sentences without physics terms. One of them here and one of them here. So I would start with reading them, but yeah, first of all, let me explain to you what happens here, what's happening in this question. So when we look at a particle Q that enters with a velocity v, enters perpendicularly to a magnetic field B, it will undergo a circular motion, actually a uniform circular motion on the third axis, not the axis of the velocity, not the axis of the magnetic field, just the third axis. A force will be exerted on it. Now, in the question, instead of obtaining Q, we got E for the charge of the electron. The velocity was named V, and the magnetic field was called B. Oh, so this is what is called Lorentz force, the magnetic force on a charged particle moving at a velocity V perpendicular to a magnetic field B, homogeneous magnetic field B. And also, we in uniform circular motion, which is this type of question, uh, the 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 sum of the forces to the directed to the center of the circle, the net force is of course as usual equal to ma, but in uniform circular motion it is equal to m v squared over r, and for the electron, in this question, we were giving ME, mass of electron. So what I'm intending to say is that we can use this. This is the net force in a uniform circular motion, and this is just the only force that we have in the question. We can write them down in an equation as being equal. This is always what happens in uniform circular motion. And then we can get rid of one of the v's, and we get some kind of a term here. And here we are finished. I want to explain why. I have this term. This is the term for the question. All the answer possibilities that include these parameters, and they are actually, of course, wrong. In order to prove they are wrong, you need to either rearrange this equation or replace v by f t omega, things that usually appear in uniform circular motion, which is, Google it. It's not, I don't want to make this video too long, but all of them are just like starting from here and just playing around with the equation and seeing if you get like answer B, the trajectory of the electron is a circle with a radius r. So yeah, if we rearrange in red what I wrote down, that's what we're gonna get. So it's good, and we're looking for something that is false. And now let's look at A, which is supposed to be the what we choose. The electron continues to move with a constant velocity v. No, it doesn't, which is like very easy, but I'm just trying to make you understand that if this was the fifth option, if it was option E, it would be harder than just. So I would recommend that in such questions, if you understand what's going on in the question, you just look at the answers. I'm usually a person like that. I just look at the answers, try to find out what I need to choose, and if I have no choice, I start solving and writing down things. So why doesn't the electron continue with the constant velocity? Because I just told you that Lorentz force states that a particle that goes inside a magnetic field and they're not parallel to each other, the a force will be exerted on the particle, and it will undergo either a circular motion if they're perpendicular and something else, but nevertheless, it's not going to be constant velocity. The magnitude of the velocity will be the same, but the direction is going to it's going to change. So the speed stays the same. This is in English. When you're talking about speed, you're talking about a scalar variable, which is just, how large is the speed. But when you're talking about velocity, as you can see in the question, v has this arrow above it. It means that it's a vector. And then when the direction changes, it means that the velocity changes, despite the magnitude staying the same. Okay, I will see you in the next question.